A very good skill to have is to be able to balance an oxidation reduction reaction equation. And you can see these sometimes, we can do equations just by looking at them and say, okay, put two of these over here, put three over here, and it works fine. We just say that's balancing by inspection. But a lot of times with an oxidation reduction reaction, it's a lot harder to do. So there are different methods, and we're going to learn the method called the half reaction method. Now, for every one of my tutorials, I always like to have a little graphic. And when I was looking for graphics, I found this really pretty set of instructions. And this is from a guy here called, Redox.com. He has a blog, and I looked on his blog, and it said, if you need help balancing these equations, go ahead and take his graphic. And so I did. I think it's very pretty. Now, here's the same method here, just written out in steps. So we're saying here is the first thing you're going to do is you're going to take your equation and set it up into two half reactions. Now your half reaction is, the oxidation half reaction and the reduction half reaction. And what you're looking for is, which chemicals are changing their oxidation state. So in somebody is going to have to change up, and another chemical is going to have to change down. So we'll be looking for those, and they're usually fairly obvious. Next thing we'll do is to go and get all the atoms and charges balanced. So we start off doing every atom we can except for oxygen and hydrogen. So we'll just get like chromiums and everybody out of the way. Then we go back and do the oxygens. Then we go back and do the hydrogens. And then we go back and do the charges by putting in electrons. So that's our step we're going to do. We're going to do any atoms other than hydrogen, oxygen, then hydrogen, then the charges. Okay, next thing we do is go back and say we're going to equalize the number of electrons lost and gained. Okay, and what we'll do there is just maybe multiply one half reaction by 2 and the other half reaction by 3. We want the electrons to cancel. And when they do, the number of electrons that cancel is the value of n. And we'll be using that for our other equations. Okay, finally we just put the two half reactions back together to get our balanced equation. And if it's in a basic solution, we have one more step, and that is, take the H pluses and add OH minuses. So we're going to see all of this as we come back. Let me kind of clean up this page. So we may use these instructions over and over. We're going to do 4 examples. So the first one I have, and across the top is our instructions again. Okay, first thing we're going to do is to say, well, here's HCl, K2Cr2O7, turns into KCl, CrCl3, H2O, and Cl2. So we've got to identify who is changing. Now, a really obvious choice here, as soon as you see a neutral element, that has to be changing, because it can't be neutral on both sides. So on the right side of the arrow, Cl2, left side of the arrow, the only thing with Cl is HCl. So the beginning of our equation is going to be HCl turns into Cl2. Now for the other equation, to me, it's pretty obvious that it's this dichromate and the chromium Cl3. And if you're not sure, you have to go back and actually figure out its oxidation number. We're going to find out that the oxidation number of Cr on the right is +3, on the left it's +6, so there is a change there. So we're going to start off this equation with K2Cr2O7 changes into CrCl3. Now, but don't worry about any other chemical because they will all come out in the wash. Everything will be fine. Let's go back to our first equation. HCl turns into Cl2. So we've separated our atoms into 2 half reactions. And in each half reaction, we're going to start balancing our elements. So let's go back and say, well, I want to balance anybody except oxygen and hydrogen. So that means chlorine. So I have 2 chlorines on the right. I need 2 HCl, so I have 2 chlorines on the left. So far, so good. Now, if we had oxygens, we would balance those, but we don't have any. We're going to go right to hydrogens. And the idea is, way back when, we learned about the Z diagram, and we know in any aqueous solution there are H plus ions and OH minus ions floating around. So we can just go ahead and put in 2 H plus ions, because they are always there in our solution. And that'll give us 2 H's on the left, 2 H's on the right. Okay, our next step is to go back, so we just did this step. Okay, next one is we're going to balance our charges. And we're going to do that by looking at both sides. Whichever side is more positive, that's the one that gets electrons. So the left side is neutral, the right side is +2. So we're going to add 2 electrons to the right side. Now, everything is balanced in that first half reaction. And because the electrons are on the right, they're being given off, then we know that this is gain, reduce, oxidize, lose. This is an oxidation half reaction. Now, let's switch colors and go on to the second equation. We have potassiums, and we got chromiums and oxygens and chlorines. So let's do the chromiums first. So I'm going to put 2 over here. So I have 2 CRs on the right, 2 CRs on the left. Now, let's do the potassiums. So on the left, I have 2 K pluses. So on the right, I'm going to add 2 of my KCl's, because that is a chemical that has K's in it. Okay, next let's do Cl's. So on the right hand side, I have 2 times 3. Okay, I've got 6 Cl's. 2 times 1, I've got 2 more. I have 8 Cl's altogether. So on the left side, the chemical that has Cl's is HCl. So I'm going to add 8 HCl's. Now, I have my potassiums and my chromiums and my chlorines. Okay, all those atoms are balanced. So now we're going to go and do our oxygens. And oxygens, we can get those. We say, here's 7 oxygens. Well, in each of these solutions, there is definitely some water. So what we're going to do is add 7 waters to the right side of this equation. And that gives us 7 oxygens. And what about the hydrogens? On the right side, I have 14, 7 times 2. On the left side, I have 8. So I'm going to add 6 more hydrogens. So now all of my atoms are balanced. Now let's do charges. Which side is more positive? And the left side is more positive. How much more positive? Everything on the right is neutral. So on the left is 6 pluses, so I need 6 electrons. And now this is a balanced reduction half reaction. I'm going to put these two equations together. So that means everything on the left side of the equation turns into everything on the right side of the equation. We want to delete anything that is common to both sides. So before we do this, we have to have our electrons, they have to cancel, because electrons can show up in a half reaction. They would never be there in the complete reaction, completely balanced equation. So we have 2 electrons on top on the right, and I have 6 electrons. So I'm going to multiply my entire top equation by 3. So that would make this a 6, and that'll put a 3 right here. That'll make this a 6, and that'll make this a 6. So now we're going to put our equations together. 6 electrons, they cancel. And just as a note, later on we might need to know that n equals 6. Whatever the number of electrons we canceled, 6 and 6, then that's the value of n moles of electrons. And that shows up in the Nernst equation and a couple other places. Now look at hydrogens. There's 6 hydrogen ions, 6 hydrogen ions, so those go away. And then there's nothing else that looks like it cancels, but we do have 6 HCl's, 8 HCl's. So our final equation here, let's put 14 in front of the HCl's. We have 1 K2Cr2O7. On the right side we have 2 KCl's, and we have 2 CrCl3s. We have 7 waters, and we have 3 Cl2s. So this is a balanced redox equation. And we could go back and double check and make sure all the atoms balance, but that's how we do it. Example 1. Example 2, let's try again. Looking at this, I kind of see that KMnO4 looks likely, and iron looks likely. Okay, because remember iron comes in 2 different states, Fe2 plus and Fe3 plus, and that looks like what's going on here. So let's try this. So FeCl2 can turn into FeCl3. In another case here, we would have KMnO4 turns into MnCl2. Now if we want to go back and double check our oxidation numbers, we'd find out that it's a +7 state on the left. No, +7, yes, +7 state on the left, and on the right side is +2 state, so it definitely is being reduced. And then the FEs are going from 2 plus to 3 plus, they're being oxidized. Okay, let's balance. In the FEs, okay, we have two FE on each side, that's balanced. We have 2 CLs and 3 CLs, so we need to get some more CLs on this side, and what I have is HCl. So I'm going to add 1 HCl to my equation. That gives me the right number of CLs, but I need to put another H, so that's going to be H plus, because they're always floating in a solution. Now we have all our atoms, we have to do charges. The right side is more positive by 1, so we're going to add 1 electron. Now for the bottom reaction, let's do the MNs. MNs are balanced, we have 1 and 1. Okay, we need a K, we need 2 CLs. Okay, so on the left side, I'm going to put in HCl, and I need 2 of them, so I'm going to put a 2 HCl. On the right side, I need some Ks, so I'm going to add in some KCl. And now that I've done that, I've actually changed my CLs, so I probably should have done the K first, but I can fix it. So on the right side now I have 3 CLs, so I need to have 3 HCl's here. That wasn't too much of a problem. Okay, now we have everything except oxygens and hydrogens. So we're going to do our oxygens first. We do that by adding waters. So I have on the left side, here's 4 oxygen atoms. So on this side I'm going to put 4 waters. Now on the right side I have a total of 8 hydrogens, and on the left side I have 3 hydrogens, so I need to balance by adding 5 more hydrogens on the left. So I'm going to add 5 H pluses. Now it looks like everything is neutral except for the H pluses, so that makes the left side more positive, and I'm going to add 5 electrons. Now if you get to this point and you have electrons on the same side of both equations, then you've made a mistake, and I just erase it and start over because it's really hard to find out where you went wrong. I just work more carefully and try again. I want to put these two equations together. So this top equation, I'm going to multiply by 5 because I want those 5 electrons to go away. And since it's all 1 to 1 to 1 to 1, it's now 5 to 5 to 5 to 5. Okay, 5 electrons go away, 5 H pluses go away. And that looks like everything. So what have I got? I've got FeCls, I've got 5 FeCl2s. It's a little tough. Put a 5 there. And I've got 1 KMnO4. I have 5 HCl's. And on the right I have 5 FeCl3s and 1 KCl. I have 1 MnCl2 and 4 H2O's. And there I have my balanced equation. 2 down. Okay, now this one's in a basic solution. Now it turns out we do this exactly like we would in an acidic solution or a neutral solution, but when we get to the last step we're going to make one little change. So it's pretty obvious here that our equations have to be S2 minus turning into S, and MnO4 1 minus permanganate turning into MnO2. Now let's do the top one. Okay, we have our S's are already balanced. We don't have any oxygens or hydrogens. So what we need to do is to balance the charges. So the right side is more positive by 2, so we add 2 electrons. Now I forgot to change colors, and that's okay. On the next one here, the MnO4, the MNs are good. We have 1 Mn, 1 Mn. Okay, we have oxygens, we have 4 oxygens, we have 2 oxygens, so I'm going to add 2 H2O's, that'll give me 2 more oxygens. I have 4 hydrogens, so I'm going to add 4 H pluses. And now we have to be a little careful. The total charge on the right is 0, and on the left I have 4 plus and 1 minus, so it's plus 3. So the left side is more positive, but positive by 3. So I add 3 electrons. Now both sides are electrically neutral. I'm going to put these two together, and I can see I have 2 electrons on the top, 3 electrons on the bottom. So I'm going to take my top reaction and multiply everything by 3. That'll make this 6, that'll make this 3, that'll make this 3. And this is a step that I try to be very careful because I make big mistakes. Now on the bottom equation, I'm going to multiply that by 2. So 2 times 3 is 6. This will be 8, 2, 2, and 4. Now, I can put these equations now together. So what have I got? I've got I've got 6 electrons, that cancels. And I have 4H plus, 8H pluses, they're not anywhere else. Okay, so I think my equation is ready to put together. So I have 3 S2 minuses. I have 2 MnO4s. And on this side, I also have 8 H pluses. On the right side, I have 3 sulfurs. I have 2 MnO2s. And I also have 4 waters. Now, my next step is this cannot have H plus ions floating around in a basic solution. Okay, a basic solution would neutralize all those. So for every H plus, I'm just going to add an OH minus. But if I do that to one side of the equation, I have to do that to the other side of the equation. And what has happened is these two turn into 8 waters. So I'm going to cross them out and add 8 waters on this side. Now my last step is to clean up the waters. I have 4 waters over here, so they cancel, and that changes this to 4 waters. So let's recopy the equation. I have 3 S2 minus plus 2 MnO4 minus plus 4 H2Os turns into 3S, 2 MnO2s, and 8 OH minuses. And that's the balanced equation for this example 3 in a basic solution. Last one, we have copper sulfide turning into copper ions and sulfur. We have NO3 turning into NO in an acidic solution. So it looks to me like sulfur and sulfur. Here I have neutral sulfur on the right, so that has to be part of my equation, and copper sulfide on the left. It must be Cu2 plus, S2 minus, so the copper is not actually changing. And on my other equation, it looks like the NO3 minus changing into NO. And again, if we're not quite sure, we can go back and check our oxidation numbers. Oxygen is -2, so this must be N in the +2 state. 3 oxygens, -2 with a minus left over, so that must be the +5 state. So it's going from +5 down to +2, where the copper is changing from -2 to neutral. Okay, let's balance. I have copper and I got sulfur. Okay, the sulfurs are fine. Copper, I need to have a copper, so I'm going to add in a Cu2 plus. And all my atoms are balanced, but the right side is more positive, so I'm going to add 2 electrons. Changing colors, I'm going to do my nitrogens. Okay, the nitrogens 1 and 1. Here I have 3 oxygens on the left, 1 on the right, so I'm going to add 2 more oxygens by putting in 2 waters. That gives me 4 hydrogens on the right side, 4 hydrogen ions. So all my atoms are balanced. Charges, the left side is +4 -1, so +3. The other side is neutral, so my left side is more positive by 3, so I'm going to add 3 electrons. Now, top has 2 electrons, this has 3 electrons, we've seen that before. So I'm going to multiply my top equation by 3, that'll make this 6. That'll make that 3, 3, and 3. The bottom equation I'm going to multiply by 2, that makes this 6. This becomes 8. This becomes 2, 2, and 4. Now I'm going to put these two equations together, and since it's acidic, I don't have to worry about doing another step. Does anything cancel? I can see my 6 electrons, and they better cancel, so n equals 6 if that comes up later. I have 4 hydrogens, but I don't have any more there. Okay, so my equation is pretty much done. I'm going to say I've got 3 CuS and 2 nitrate ions. But I also have 4 H plus ions. I'm going to throw those in. I have 3 copper ions. I have 3 sulfur atoms. I've got 2 NOs, and I also have 4 H2Os. And that's my balanced equations. That's it for now.